Hi everybody, let's have a look at the written homework for week 2. On number 1, so most people got that, you have to either know the 3, 4, 5 triangle or use the Pythagorean theorem to find this side. So you get 3, but the thing is, it's plus or minus 3. It really depends on what quadrant you're in. So probably the biggest mistake when you're learning trigonometry is to forget to think about what quadrant you're in. We're in quadrant 3, and in quadrant 3, the vertical coordinate of this point has to be negative. So when we use the Pythagorean theorem and we take a square root, we get a plus or minus because we took a square root, but we have to choose the minus because of the quadrant we're in. So this is really minus 3. Also, this 4, I intended this 4 to tell you how long this line segment is, not to tell you what this coordinate is. And this coordinate has to be negative, again, because we're in the third quadrant. So this coordinate isn't positive 4, it's negative 4. So, a lot of people were missing minus signs on some of these trig functions because they just weren't thinking about the quadrant you're in. So always think about the quadrant you're in. On number 2, so I asked you to write cotangent in terms of cosine, and a lot of people wrote cotangent theta is cosine theta over sine theta, and then they just stopped. But this isn't in terms of cosine yet because we have a sine floating around, and when I say cosine, we want all cosines. So we need to get rid of this sine theta somehow. We need to write it in terms of cosine, and the most straightforward way to do this is, the relationship between sine theta and cosine theta is the Pythagorean identity. So we can use this to solve for cosine theta, but again, we have to take a square root. And when you take a square root, you have to think about what quadrant you're in to figure out if you want the positive or the negative. Well, in quadrant 3, cosine is positive, but this square root is negative, this cosine is negative in quadrant 3. The square root itself is positive, so we need to choose the negative here to force this expression to come out negative because we're in quadrant 3. So cosine theta over sine theta becomes cosine theta over negative square root of 1 minus cosine squared theta. So some people were missing this minus sign, some people just left it like this. Another popular mistake was just to make algebra mistakes when doing this computation. So, be careful about your algebra and check what quadrant you're in. On number 3, so probably again the biggest mistake was just not checking what quadrant you're in. For all of these, so here we're in quadrant 2, but in quadrant 2 sine is negative, so we need cosine is negative. So we need a minus sign right here. Also, a lot of people wrote root 3 over 2, but that would be if the angle was 5 pi over 6, not 2 pi over 3, so careful there. In this one, we're in quadrant 3, and sine is negative in quadrant 3, and then in this one, we're in quadrant 4, and tangent is negative in quadrant 4. So be sure you're checking what quadrant you're in. On number 4, so far and away the biggest mistake that people made on number 4, actually I guess there were 2 common mistakes. One was putting the 20-degree angle down here at the bottom of the triangle instead of up here at the top. If you read the problem, it says that this 20-degree angle has to be at the top of the tower. So the 20-degree angle goes up here. The other really common mistake was when you use tangent 20 degrees to get x over 100 here, right? We get this. And now we just need to dump this into a calculator. And I could tell that many people had their calculators in radian mode because they just didn't get the right number. They got 200 something. But that wouldn't make sense because, I guess it's possible, but it's not very plausible with this upper angle being only 20 degrees. It's not plausible for this horizontal distance to be 200 when the vertical distance is only 100. People that made this mistake tended to get a value for h that was actually smaller than 100. So how could this hypotenuse be smaller than the leg? That just doesn't make any sense. So be sure, whenever you go for one of those trig function buttons on your calculator or the inverse trig buttons, be sure to check what angle mode your calculator is in. and just make sure that it's using the same units as you are, because otherwise you're going to get answers that are totally wrong. On number 5, one common mistake is actually what I did at first, which is this shift is to the left, right? Horizontal operations work backwards, so you'd think that adding something would move it to the right, but in fact it moves it to the left because horizontal operations work backwards. So it's a shift to the left here. Other than that, probably the most common mistake was having the wrong period. So remember, the relationship between this number, which I've been calling omega, but the book seems to call b for some reason. Either one is fine. I like my notation better, but then I would. That's why I use it. Whatever you use for this coefficient, the relationship between this coefficient and the period, which usually gets called capital T, is b equals 2 pi over capital T. And it's 2 pi when you're using sine, cosine, secant, or cosecant, because 2 pi is the period for these functions. If you're using tangent or cotangent, you'd have a pi up here instead. So for us, this coefficient is pi over 6. So we get pi over 6 equals 2 pi over t. And then we need to solve for the period, capital T. And you get t equals 2 pi divided by pi over 6. And then you have to simplify this fraction, and you get 12. So the period is 12. Some people seem to think it was 2 pi or 12 pi, or I don't know. There are lots of different answers there. But once you know the amplitude, the period, and the horizontal shift, there's no vertical shift, then you can get the correct graph. So I guess big takeaway for this one is be careful with your algebra and always check what quadrant you're in.